last video, we looked at writing chemical formulae because it's important you can do that confidently before you can apply it to writing balanced chemical symbol equations. So please do check out that video if you haven't already done so. In this video, we're going to focus on actually writing balanced chemical symbol equations, and we're going to start by looking at the state symbols. So the state symbols in a chemical equation tell us what state the element or the compound are in. And they're pretty obvious, they're pretty straightforward. So if you have an S in brackets, it tells you it's a solid, an L in brackets tells you it's a liquid, a G in brackets tells you it's a gas, and AQ tells you that it's aqueous, and aqueous basically means that it's been dissolved in water. So there are groups of compounds or types of compounds that will have the same state symbols. Acids, for example, so all acids will be aqueous, so they will always have the state symbol AQ. Alkalis will also have the state symbol AQ, remembering that alkalis are metal hydroxides, well, the majority of them will. You'll see later in the course that some of them aren't very soluble, but you'll address that later on in the course. So group 7, good, you need to know the state symbols of group 7, that'll be really helpful. So fluorine at room temperature is a gas, chlorine at room temperature is a gas, bromine at room temperature is a liquid, remembering that the boiling point increases down the group, and iodine therefore is a solid at room temperature. And then you've got your other common gases such as oxygen, carbon dioxide, hydrogen, nitrogen, and so on. Now that we've looked at state symbols, we can look at balancing symbol equations, and I'm going to give you some tips and advice on how to easily, or to help you balance equations more easily. Tip number 1, you can only balance equations by putting numbers in front of the element or compound. You cannot change the actual formula of the element or compound. Let's have a look at this example. We've got sodium reacting with chlorine to make sodium chloride. Now I will see so many people on many occasions putting a little 2 next to the Cl in sodium chloride. That is incorrect. You cannot change the formula of sodium chloride. According to the swap and drop rule, the formula is NaCl and it cannot be changed. So the only way that we can balance it is by putting numbers in front of the element or the compound. Now we can see on the left we've got Cl2, so that means we've got 2 chlorines. So we do need to make sure we have 2 chlorines on the right of the equation. The only way we can do that is by putting a 2 in front of the whole compound. So now we've got 2 NaCl. Now that the sodiums aren't balanced, so we now need to balance the sodiums because I've got 2 on the right, so I need to have 2 on the left. So I put a 2 in front of the Na. That equation is now balanced. So that's my tip number 1. Tip number 2, balance elements last. So if you have an element on its own in the equation, everything else is a compound, try and balance the element last. It will make your life so much easier. So here's an example with combustion equations. So I've got the combustion of propane, and it's complete combustion, so it forms carbon dioxide and water. So I've got all compounds except for oxygen. So oxygen is the only element. So I'm going to balance the oxygen last. I'm going to balance the carbons and the hydrogens first because they're all involved in compounds. So I've got 3 carbons on the left-hand side, so I need to have 3 carbons on the right-hand side. Remember, I can only put numbers in front, so it needs to be a 3CO2. I've got 8 hydrogens on the left, but I've got 2 hydrogens on the right. So to balance that, I need to put a 4, because to give you the total number of hydrogens, you multiply the number in front by the little number next to the hydrogen. So in this case, it's going to be 4 times by 2 gives us 8. So that's now balanced. Now I can look at the oxygens because the carbons and hydrogens are balanced. So on the right hand side, in the CO2, I've got 3 times by 2, which is 6. And in the H2O, there is no number next to the oxygen, so there's only one of them. So it's essentially 4 times 1, which is 4. So 6 plus 4 gives us 10. So I need to now make sure I've got 10 oxygens on the left-hand side. It's diatomic, it's O2. So I need to put a 5 in front of the oxygen because 5 times 2 gives us 10. My final tip for balancing symbol equations is this one. If you have an even number of atoms of an element on one side of the equation and an odd number of the same atoms on the other side of the equation, you can find the lowest common multiple. In this example, we've got nitrogen reacting with hydrogen to make ammonia, NH3. And we can see that on the left-hand side, hydrogen is diatomic, so I've got 2 hydrogens. But on the right-hand side, in the compound, it's NH3, so there are 3 hydrogens. So to balance the hydrogens, I can find the lowest common multiple. So the lowest common multiple of 2 and 3 is 6. So if I make 6 hydrogens on either side, they will balance. So to make 6 hydrogens on the left-hand side, I put a 3 in front of the H2 because 3 times 2 gives us 6. And for the NH3, to make 6 hydrogens there, I would need to put a 2 in front of the NH3 because again, 2 times 3 makes 6. The hydrogens are now balanced, and as a result of balancing the hydrogens, I've now also balanced the nitrogens. So I've got 2 nitrogens on the left and 2 nitrogens on the right. Thanks for watching. For more chemistry tips and revision, hit subscribe, click on the like button, and check out my Instagram page using the link below.